Hello everyone, I am Dr. Rajesh and I am again with you with my new video lecture. In this video lecture, we will study how to find components of a given force along given directions. So, let us see the scenario, that what will be the scenario in this case. Let us say this is the given force, say R, and we have to find its components in the given direction. Say this is the direction and this is the another direction. So, complete the parallelogram and the force now this given force R is to be resolved in this direction and in this direction. So, earlier the case we have studied, in that we are making the clear contrast between this study and the earlier study that we have carried out. In that case, two forces were given like that, and one force was along this direction, another was along this direction, and we have completed the parallelogram, and their resultant was given by the diagonal of the parallelogram. Okay, so in this case the forces were given and we have determined the resultant. I am writing over here forces were given and we determined resultant, that is earlier article that we studied. Firstly, we should know that what is the difference, why we are making the new study. But in this case, force is given and it is required to be resolved along two given directions. So, and when the directions are given, then the angle will be given also. So, say this angle is alpha and this angle is beta, this angle is beta. So, we have to determine the component P and component Q. These are to be determined. P and Q are to be determined. Now, if you see over here, this angle is beta, this is alternate angle. So, this will also be beta, this angle will also be beta. And if you see the sum of the three angles, alpha, beta and this one is 180. So, this angle will be pi minus alpha plus beta. This angle will be pi minus alpha plus beta. So this is P, and which is required to determine this is Q. So you could also name the points A, say this is B, this is C, this is D. Now applying sine law in triangle A D B, we have firstly write the sides AD, BD, AB divided by AD. This one opposite angle is pi minus alpha. So sine of that, sine pi minus alpha plus beta, and the bar over alpha plus beta is the smallest bracket. BD. This BD opposite to that angle is alpha. So this will be sine alpha. AB. This is AB and angle opposite to AB is beta. So this will be sine beta. Fine. Now these sides are representing the forces. AD is representing R. So this will be R, and sine pi minus alpha plus beta will be sine alpha plus beta. BD is representing Q. So this will be Q sine alpha, and AB is representing P. So this will be P by sine beta. This further implies that from these two ratios, as R is known, alpha and beta are known, this is known quantity, this quantity is known, sine alpha, alpha is known, this is known, Q is to be determined. So from first two we can write Q is equal to R sine alpha divided by sine alpha plus beta, because this will go over here in the numerator. So this will be the result. Similarly from first and third, this one first and third taking, and this will go over there. This is from first and second ratios, and P is equal to R sine beta divided by sine alpha plus beta. This comes from first and third ratio. Okay, and how you will commit it to memory? Like we have to determine P. Look, when here is P, the angle resultant making with P is alpha and with other force is beta. So you see, when we have to determine component P, we will write R sine of the other angle. Primary angle is alpha, that this force is making with R, other is beta. So R sine beta, other sine beta, sine of sum of the angles alpha plus beta. Similarly, when we are required to determine Q, it will be R sine of the other angle, beta is the primary angle, in this case other angle is alpha, sine alpha plus beta. So how will you commit it to memory? CTM means commit to memory. Component of force along given direction is equal to R into sine of other angle divided by sine of sum of angles. So I hope I am clear in illustrating this concept. So now we will move somewhat further. We will see whether this thing applies in case of components which are at right angle to each other. So let us say this is the resultant R and is required to be resolved into components which are at right angle to each other, and the forces are given the same. This is alpha and this is beta, and say this is P and this is Q. Now complete the, if you want to complete it, you could complete the rectangular shape. In this case, alpha plus beta, as it is clear, alpha plus beta is 90 degree. This angle is 90 degree. So alpha plus beta is 90 degree. One condition is this one. So if I say this is O, this is X, this is Y, component of R along OX is equal to, now write the above formula, R resultant as such, into along axis P, the primary angle is alpha, other angle is beta, into sine of other angle is beta, sine of beta, sine of sum of the angles alpha plus beta, which is 90 degree. R sine beta is equal to sine 90 degree is equal to R sine 90, you know, is 1. Similarly, component of R along OY is equal to R. You see, the primary angle in this case will be beta, other angle will be alpha. Sine of other angle divided by sum of the angles alpha plus beta is equal to R sine alpha, sine alpha plus beta is 90 degree, and you know is equal to R sine alpha. So one component is in terms of beta, other is in alpha. So let us make this as also in terms of alpha. We know that alpha plus beta is 90 degree, so beta will be 90 minus alpha. So from here we could write this is equal to R sine 90 minus alpha, which is further equal to R cos alpha. So this component will be R cos alpha, and you know, if this angle is alpha, the component with which it is making angle alpha is cos of alpha. So R cos of alpha, and other angle will be R of sin alpha. It will be sin alpha, R sin alpha, which is same that we have obtained over here. So this formula is important, and this formula is particularly in case when we are required to determine the components of a given force along given directions. So that particular formula will be used very frequently. So with that, I will conclude today's lecture, and I hope that you will be able to understand the concept discussed in today's lecture, and in the later lectures I will be taking the problems based upon this concept. So till then, take care, bye bye, and keep studying, keep learning, and thank you for watching. I will be back with my next video lecture very soon. Till then, take care, bye bye, see you soon. Thank you very much. This is Dr. Rajesh saying goodbye.